from our other speakers through the week. If you haven't, we can send you the list of sessions and you can watch the recordings. So we do have an incredible line of speakers here with me. So without taking much time, let's get started. A quick preview into what to expect for this session. We are going to focus on how to design a cross-cloud network to enable a secure and optimal experience for your hybrid workforce. We'll go through a quick recap of how far we've come along since we launched this last year at Cloud Next 2023. Then we will do a deep dive into the technical architecture. And we also have our esteemed customers joining us to talk about how the solution is enabling their organization in terms of addressing some specific business challenges. So what is Cross-Cloud Network? Cross-Cloud Network, it's an open platform with built-in security and is performance optimized to allow you to provide a secure and optimal experience for your users who are accessing your distributed applications that are running in Google or that are built using Google's best-in-class services like our AI services. It enables you to build a distributed application stack anywhere in any cloud using our Google first-party services. You can provide the most optimal experience to your end users when you deliver these distributed applications over our global front end. And finally, you can ensure a secure access to the private applications for all your hybrid workforce, whether your users are connecting into your network remotely or from a branch or a campus location. We already have 5,000 customers on Cross-Cloud Network, and 60% of them are amongst our Fortune 50. So we'll focus on the hybrid workforce use case in this session. Before we go into the technical architecture, let me just set some context on some of the problem areas that we are focusing on and how that maps to the various use cases. So as we know, there are two most common deployment models for a branch. You have the distributed enterprises, where each branch is connecting to the cloud, or it's sending traffic to internet or SaaS. And the internet security for these branches is enabled using firewalls in the branch. The other model is where you want to aggregate your regional branches within a co-location, and you're aggregating some of your other services in that co-location also. And within the co-location, you deploy virtual or physical firewalls to enable security for the user traffic. And this could be traffic that is SaaS bound, internet bound, or going to the public cloud, trying to access private applications. So as you can see, all the on-prem traffic is being secured using a firewall endpoint. Whether the firewall sits in the branch or it sits in the colo, that's an architecture choice. Now most of the enterprises, they also have remote workforce. And one of the primary solutions for connecting and securing remote workforce traffic is to use SASE solutions. So imagine a user that goes to office 2 days a week and works remotely for the remaining part of the week. For the 2 days that they are in office, all their traffic is going through the firewall. For the remaining 3 days, they are probably connecting into a global SASE service, and that's where the security controls are also being applied. From a security posture perspective, this creates a lot of disparate security posture, because these products and security controls, they are very different. They're often from multiple vendors. Then, from an admin perspective, they are managing these two separate stacks for securing the same user based on the location of the user. So it's operationally expensive, it's a lot of overhead. Enterprises also need a global, reliable, high-performance connectivity for all of these locations. For site-to-site connectivity, site-to-cloud connectivity, site-to-internet connectivity. And we all know that most of the enterprises are using traditional backbone solutions like MPLS or colo-provided solutions. So what is the big challenge? The big challenge is when something goes wrong, it's very hard to troubleshoot, because more often your backbone is going to span across multiple providers. The second challenge is it slows down your pace of innovation. So if you need to deploy a new circuit because you have a new location that's come up, you have to call up your ISP, open a service ticket, they'll deploy a new circuit for you. And once that happens, only then you can start using that circuit. And the third challenge is you want to enable privacy and security on top of these circuits, which requires you to run some kind of an overlay encryption, which adds another layer of cost and complexity. So now let's look at how we are trying to solve these various problems for the branch users using our cross-cloud network principles. So let's start with the backbone. We offer a global VPC-based architecture. So by default, all of our customers get access to a high-performance backbone with our premium tier network, which gives you full global connectivity. It gives you a fully encrypted backbone. It's a fully managed backbone, so you do not need to create those overlays that we just talked about. And you can bring in any locations in any regions without having to call us to set up a circuit for you. Our premium network extends our backbone closest to the user. We have more than 187 POPs in 200 plus countries, and you can advertise your service IP through each of our edge POP locations to bring in the traffic into the Google network from our closest location. And you can have the best network reachability. We are the best network reachability provider amongst all cloud providers. We have the maximum number of private peering points for any cloud provider. So that's about the backbone, a fully managed backbone with a premium tier network. Now let's talk about security. Security for the user traffic requires many different types of security controls based on where the traffic is going. So you may need a different type of a security control for SaaS traffic. You may need different types of security controls for internet-bound traffic and private apps. So while we continue to invest into our first-party services like Cloud Mention Firewall, we also understand that security is a best-of-breed market. And a lot of our customers, they already have a preference for a firewall provider or for a SASE provider as they are bringing their traffic into Google Network. And this is where we are working very, very closely with our partners to bring in their SaaS services as a native service into your VPC in Google Cloud. So you can consume those third-party services just like you would consume any other GCP native service in your VPC today. And we'll talk about that in a little bit more detail. So how does all this benefit you? You can enable a consistent security posture for all your users, whether they are remote or they are on-prem. You can have the most optimal experience for those users because you minimize the amount of time that the traffic stays on the internet. And you can also achieve some cost benefits as you consolidate your assets and you move to a consumption-based model with our backbone as well as our security offerings. We have 3 of the top SASE providers hosting their SaaS services in GCP. And we are already integrating with two out of those using our Secure Access Connect integration. So how does this work? So you bring your user traffic into GCP using our network connectivity services that we just talked about. Once the traffic is in GCP, we offer direct peering into the third-party SaaS provider. So your traffic is sent into the security service over our backbone. It goes through security inspection. And if the traffic is allowed to go through, we then find the best path to send that traffic to its destination. So if the traffic is SaaS bound, we will send it over our backbone to the best peering point to the SaaS provider and hand it off to the internet. For private applications, the traffic will head back into the customer's VPC, and using our backbone, it will be steered to your application VPC in Google Cloud. So it does not go over the internet. And if the application is in another cloud provider environment, we can still steer the traffic over our backbone, over our cross-cloud interconnect, and hand it over to the other cloud provider using the best peering location with that cloud provider. And since our backbone is fully encrypted, you don't have to build overlays as the traffic traverses regional boundaries. So we are currently partnering with Palo Alto Networks and Broadcom Symantec to jointly deliver this solution. And a quick update on how far we have come. So we announced this at Cloud Next in 2023. Since then, we've added a new SASE vendor to our portfolio. Fortinet made an announcement last year. They are expanding their 40 SASE service in GCP. In terms of our integration with Palo Alto Networks is currently in preview. We have customers testing it out in high-scale deployment environments. And I'm very excited to announce that we are going to be previewing our .com integration very, very soon in Q3. Our partners see a lot of value in working with us because our solution, our infrastructure allows them to scale faster and serve their customers better. And we embrace our partners and we are working closely with them so you can have the best of both. But we are not stopping there. And before I hand it over to the next speaker, let me share how the solution is evolving further for the branch users based on some of the other challenges that we are hearing from our customers. One of the biggest costs when you have branches is the management and the operational cost of those branches. The branch environment spans across networking, security, IoT, and a lot of other assets. So it's a very, very complex environment. Deploying a new branch or servicing a branch when something is broken requires truck rolls, and that makes the process slow and expensive. And I've heard this from many of my customers, that the cost of replacing a broken hardware in the branch is sometimes higher than the cost of the new hardware itself. Right? So that is where the idea of aggregating the branch services in a regional site, it sounds very, very exciting. So while the idea is exciting, the execution is very challenging because now you have to manage the scale, reliability, site survivability, and a lot of those other aspects to maintain the same SLAs that you had when these services were running in the branch. And this is where Cross-Cloud Network comes in, where we are taking a slightly different approach. First, we are working with our partner ecosystem to deliver the services of your choice as SaaS services in GCP that you can quickly and rapidly deploy from any of our regions. Next, our global backbone will ensure that your users who are using these services have the same experience as if these services were running in your own environment because of the low latency network that we offer. And finally, we are automating service stitching for you. So imagine you're running a firewall and your NAT appliance, and you configure the firewall and the NAT appliance for internet security. And you have to make sure that firewall policy is applied before the NAT policy, and not vice versa. So a lot of this logic is going to be automated as part of our solution. So while we continue to innovate on simplifying the networking and the security for our branch users, we're also extending the benefits of CCN to transform traditional branches and evolve them towards a cloud branch. We have a growing ecosystem of partners to offer you the flexibility of the services that you want to consume, while we focus on simplifying how you consume those services. And with this, I would like to invite Chris. Chris is a senior cloud architect at Priceline, and he will talk to us about some of the changes and transformations that his organizations are going through, some of the challenges, and how you look at CCN as an enabler for your organization.
Awesome. Thanks, Manisha. Great to see everybody here. Hope you all enjoyed Cloud Next. It's fantastic here in Vegas. As Manisha said, I am Chris Muir with the Enterprise Architecture team at Priceline. Priceline is an online travel agency in business over 25 years now, helping people enjoy the moments that matter. And as we do that, we've grown into a global organization with offices and employees across the globe in Asia, Europe, and in the Americas. So with that workforce spread so wide, we have to consider how we support that workforce. So where is that workforce? Like probably most companies, that workforce is everywhere. They're in branch offices. They're in their homes. They are working off of VDI. They're out of hotels or casinos, or they could be on a beach. At one point, I had a user that was on a boat at the end of a dock, right? So they are everywhere. where are the resources that all of these folks need to get to? They're in for Priceline, there's some co-location that still resides. We're in multiple clouds, multiple SaaS providers for services, as well as in our branch there are services folks need to access in terms of printing. How do they print things that they need to print? And yes, people still print. I'm surprised by that. And there are also conferences, conference spaces that need to be supported. So there's where that workforce resides, as well as what they need to access. So how do we consider this at Priceline in terms of evolving what we do and how we do in supporting these users? Well, is VPN enough? And in the evolution of our cloud journey from co-location, how do we reduce dependencies from the colo and wide area network to the branches and those client VPNs? So as we think through this, we know we need to approach this in an iterative way. It has to be cost effective. It needs to reduce toil on our teams that support those end users and endpoints. It needs to be a simplified approach so that it can provide a consistent, performant user experience with minimal friction for those folks. So that's really our North Star in terms of what we want to provide to our end users. A consistent, zero trust supported everywhere approach that's encrypted, authenticated, and authorized. All right, so what are the options for us to get there? And how we think about where we evolve to support that North Star. Some considerations we put up on the board here and tried to weigh out some of the pros and cons and how we approach it across those key points I mentioned. Uber proxies and identity-aware proxies are great in terms of the lack of the need to support agents on the endpoint, so that's fantastic. It removes a layer of toil. But on the flip side of that, the requirement of publishing those availability targets, who gets access to those published targets, and how you manage that in its life cycle and its ongoing process creates another layer of toil. So there's a con to that side. Connectors are a very promising target for us, although as we look at them, even though they remove that need for the agent and the VPN client, they provide a new set of technology and infra that needs to be deployed and managed. That means that we need to invest capital, we need to invest deployment and project efforts, we need to invest in users to onboard this new technology and be able to adopt it, and we need to invest in how we support it from a skills perspective for our resources. So that's kind of the con to that. It seems to be a good target for us, but probably maybe a later iteration. Agents and SASE, which has already been talked about by Manisha and repeatedly, I think, in the conference, is an existing behavior for us. We currently leverage a SASE service to support our remote users. So agents are already present, so that's great. This is already kind of in place. It's an existing behavior. But still maintaining updates, the enablement of different resource reachability, different authorizations, that is something that is kind of a con for us, and maintaining an always on posture with those agents is also a challenge, especially in things like at a hotel where you have captive portals to consider. Lastly, browsers was another key target for us in supporting endpoints that aren't managed by Priceline, whether those are consultants or vendors or even personal devices, right? It's a nice solution in that it does not require any endpoint agent deployments, so it's flexible. But it does have some cons and some use cases where some folks prefer a particular type of browser, or how you publish different resources and manage those published assets. So those are kind of the options that we laid out. Right, so what was our approach here? After weighing those options, going over the key topics, and you can see them laid out here in terms of our considerations, we'll walk through them. So the consistent user experience. Key there, the design and deployment, right? So we need to support remote anywhere. We covered that extensively, whether that's airports or homes or captive portals, schools, basketball games, etc. We also need to be able to support the thin branch. So In our model, we want our branches essentially to be Wi-Fi only cafes, which is similar to any of the other use cases. Moving right along to that consistent user experience. Considering operations, we also have to think about how you manage endpoint health in all those scenarios, and how you optimize routing in those scenarios to the resources that are required for those endpoints. Reducing toil is key here in terms of the continuing effort to develop different services as we make our cloud journey. So things like hardware overhead is something we want to reduce. In our SASE environment, while we tie into our co-location, how do I reduce that footprint? Can I anchor that to something like Manisha is talking about, and Tom and Victor will get into that in a little more detail. How do I reduce that footprint of hardware? I've got large appliances that need to be maintained. They consume power, they consume space, they require the circuits that Manisha talked about. So being able to collapse some of that's going to reduce the toil for my teams, as well as reduce the dependencies on that co-location. Last piece, cost effective, so two more. From a cost effective perspective, we want to reduce or repurpose technology and skills. So we're repurposing our SASE provider capabilities in terms of what else can we support within that, and we're going to touch on that in the next iterative approach. By doing that, it's cost effective in the way that I'm not introducing new technologies that not only have to have a capital impact, but they have an impact on the user base, the project flows, and the skills base that our teams have supported. Traffic considerations is another component of cost. So how does traffic flow from the endpoint through the SASE in to get to the resources we need to get it to, and what are those cost implications on the different ways to traverse those paths? Is there a lower cost path that is the most effective, but we may need to fail back to something that's maybe a little higher cost? So how do we prioritize that and think through those pieces? Last piece, iterate. I think this is key in terms of how you move towards your end goal. Repurposing and hardware, really kind of beat that one to death, but essentially existing hardware is there. How do you manage the routing and provide minimal changes? Leveraging the user application and application ID security perspectives for your SASE to help improve that zero trust capability. Incorporating cloud native security. Things like Cloud NGFW are fantastic. We're looking forward to experimenting with that piece, as well as leveraging things like VPC service controls to contain public facing assets like BigQuery or GC, Global Cloud Storage, or even AI and ML. We have more and more use cases every day that come up. Cross-cloud networking is another key asset that we've talked about here, which is going to be key for our multi-cloud footprint and how we provide that pathway over to those resources. Lastly, the SaaS support in terms of how we surface that for our partners and provide IDP controls around that, again, providing that zero trust capability. All right, well, thank you, everybody. I'm going to turn it over to Tom, who's in our network engineering team, and can talk more about some of the nuts and bolts with us.
Hey everybody, I'm Tom Briggs. I'm a principal network engineer at Priceline. As Chris mentioned, we're an online travel agency, and our mission is to be the best travel data linkers in the world. So we're here today to talk about how the cross-cloud network solutions help us focus on how we achieve that with technology and productivity. We were honored to present alongside Victor and Manisha last summer to talk about how all the cross-cloud solutions were coming to market. And we're here to give an update on kind of how we're thinking about that and where we're starting to import those solutions across our architecture. So at Priceline, as Chris mentioned, we've been in business for quite a while. We have challenges where we have a lot of hardware, virtual and physical, that we manage across multiple vendors and in many locations. So as we think about this, there's the considerations of Where are we mounting this gear? What kind of relationships do we need to maintain to support all of that? What kind of circuitry do we need? How do we monitor that bandwidth? How do we plan for capacity changes? There is multiple route domains and environments that we're constantly monitoring with disparate sets of security postures that are managed over multiple vendors, right? So we have our work cut out for us, especially as we continue to actively migrate workloads to our multiple clouds that we operate in and co-location, right? The concepts of perimeter versus workload security become increasingly important as you start talking about all of the different environments where you expect to operate, and needing to build a cohesive security posture strategy based around identity is critical to operate at scale. So, we have all of these challenges. We have a hungry workforce that wants to build. We really want to provide a self-service development environment that allows us to reduce time to market for products and Gen AI services. One of the big projects we have at Priceline is a chatbot called Penny that allows you to plan your trip and ask questions about the travel experience you're booking, as well as answer some customer service related questions to kind of help you navigate the platform. We also are using AI to focus on pricing and inventory management and a number of other business initiatives. So, like Chris was saying, we are focusing on a consistent zero trust approach for our workforce as we return to office. On top of all of these very intricate challenges, we have people coming back from working full-time remote for the past couple of years. We have people who are working with us as partners in other companies and as affiliates. And we need to be able to provide access to all of our services and workloads without really having to think about, can I access this workload from X location? It needs to be everywhere. What kind of service controls and security controls are there? They need to be present. They need to be easy for our teams to deploy and maintain, and they need to be observable so that we can take action for risks and mitigation of different things that might come up. So what are the opportunities in this cross-cloud solution that we are looking to leverage, right? Cross-cloud interconnects you've heard quite a bit about throughout the conference. We're definitely working on leveraging that piece. As Chris mentioned, we're an active SASE customer, so we're looking to build out that existing tenant to support more of the cross-cloud components that are critical for our business. We leverage an infrastructure as code pipeline, so we need to be able to continue to manage all of these pieces using that pipeline. And we want to surface all of the great Google APIs available today while continue to increase our connectivity and performance with the SASE partners that we work with as well. So our requirements for all of this across various endpoints, managed and unmanaged, user machines, VDIs, etc. We want that uniform connectivity experience. We want a uniform set of controls focused around identity. We need to be able to have great visibility on that inspection and continue to work with that infrastructure as code pipeline, all while maintaining high performance and a resilient experience for our international workforce. So what does this look like? Over the past 2 years, Priceline has really focused on a WAN consolidation effort that's focused on a combination of how our workloads have migrated into our multiple cloud service providers, minimizing our co-location footprint, as well as really enhancing, like I said, that security control. We are focusing on building out branch offices that are mainly internet egress only locations where people can come to work, kind of cafe style, as Chris mentioned, and pushing our perimeter and inspection out into the cloud to be able to pull that inspection together in one place. This allows us to reduce everything you see in that circle on the left, which is a collection of hardware, MPLS we manage, multiple circuits across multiple locations, and pulls us into the right, where we are able to adopt that secure services edge model. Apart from the reduction in complexity, we're talking about being able to leverage more benefits in malware protection and URL filtering, DNSSEC, CASB, DLP, you name it, which we're, really looking forward to being able to leverage, as well as being able to, like I mentioned before, take advantage of all of Google Cloud's API library, the services we'll expose by PSC, as well as the rich SaaS connectivity partnerships that Google Cloud has to offer. On top of all of this, being able to attach that to multiple clouds at high speeds with encryption is totally critical and will allow us to continue to build out all sorts of applications. So we're planning on migrating an existing SASE tenant. Victor will be up here just a moment to explain how Google Cloud will help us do that, while easing migration with minimal disruption. We are continuing the adoption of cross-cloud interconnect to continue to scale out our multi-cloud solutions, as well as how we think about connecting private cloud and branches. And then obviously looking forward to deeper integration for our users into the cloud stack to be able to support those security controls. So without further ado, I'll introduce Victor Moreno to continue the discussion on the design.
Thank you, Tom. So let's talk a little bit about how we actually design this. So we've heard a lot about the cross-cloud network. If you look at what's behind me, that is a canonical proposed design. Yours may look slightly different from that, but basically we have in a VPC all the external connectivity, everything that's going to go to other clouds, that's going to go on-prem, and then you have a series of application VPCs where you may have API consumption, where you may have workloads, whatever you may have there, right? And there's a notion of centralizing services. Satish had an entire session on how to design this thing. Now, that gives us application-to-application communication, right? And what we're talking about here is very specifically user-to-application communications and how we secure that, right? So the first thing that we're going to do is we're going to add to this a sandbox for the users, basically a segment inside of Google Cloud, which is basically in the form of a VPC. So they're segmented off. That doesn't actually get to the applications just yet. If you have sites that have a mix of users and application resources, we basically peel off the subnets and VNets that have the users and actually make sure that they are in that sandbox. If you have sites that are purely for users, then we can bring them onto the cloud directly, either with cloud interconnect or HTTPN or your favorite flavor of SD-WAN. We have a series of options on how to do this, but basically everything is in the sandbox, and we basically created a trust boundary. Right? So at this point, we're very well segmented users from applications. So this is the same application network design, a little simplified. I moved it all to the right so we can talk about this a little more clearly. And we have our users on the left-hand side. And we also have an SSE stack. And SSE is Secure Services Edge, is part of the SASE architecture. This is basically the security stack in SASE. And in many cases, and I believe this to be the case also in Priceline, and many of you probably have this, you're already using an SSE service. Zscaler, or Prisma Access, or Broadcom WSS, and the list goes on forever. But whatever you may be using, you're bringing users and mobile users directly to the SSE service. So you got users also connecting directly there. Some are cloud connected, as you can see in the diagram. And for the most part, the SSE service gets you to public applications on the internet, SaaS applications. Right? So what we're after here is how do we actually expand the footprint of that SSE service so that you can get users that are directly cloud connected as well as private applications into the mix of that security stack, and avoid basically what Manisha was talking about, where you have different stacks and you're basically at a loss when you're trying to prove posture. Right? I've got 3 different stacks, and I'm like, okay, so I can guarantee you, boss, this thing is working and it's trustworthy. And I say, well, you've got 3 of them, so there's got to be a gap somewhere. In any case, we're going to basically make sure that every communication between users and applications goes through the SSE service. And the other thing that's happening here is that those SSE services happen to be hosted in cloud. And the ones that we partner with happen to be hosted in Google Cloud, but they are in their own organization. And you want to bridge the assets of your organization to this without going out to the internet with IPsec tunnels and coming back in. So we basically introduced a resource that we call the Secure Access Connect. I would say we're not very good at naming things, but that's what we call it. That gets us between untrusted and trusted, but it also gets us from the customer project to the SSC project and back. That SSC project is owned, managed by the SSC provider. So you buy this as a managed service from Prisma or Palo Alto, or you buy it from Broadcom, and as we grow the ecosystem, you can buy from anybody else. So we're basically creating a cloud-native bridge between this, and what it looks like is more like this. The SAC, or Secure Access Connect, is a regional resource that is going to connect directly to a regional instance of the SSC stack. So think of your SSC stack as a series of nodes that are across a multitude of regions. And if you have any experience doing the SSC thing, you know exactly what I'm talking about. Well, we're going to basically create a Geneve tunnel between the SAC and the SSC stack, and we're going to BGP peer with that. And we can do that in multiple regions. And we'll talk a lot about that in the next few slides. In any case, that's the northbound interface. That's what gets us between projects, and that is cloud native. The Geneve encapsulation is negligible in terms of performance. This is not the same as if I was to encrypt traffic between the SAC and the SSC node. Okay? So that's one big gain in performance. And then on the southbound side, we've got two legs, right? One facing the users, that's done with VPC peering, and then we participate in an NCC hub as a spoke for the application part of the house. So we have the notion of on-ramp and off-ramp in SSC land, and not all providers of SSC use this nomenclature, but I think it's handy for what we want to explain here. So when we say on-ramp, we're talking about bringing traffic from cloud onto the SSC stack, and off-ramp is basically the converse. Once it's been processed and secured, we bring it out of the, and you can configure the Secure Access Connect in on-ramp, off-ramp, or both. If I configure it for on-ramp only, you can see two flows that are supported here, from mobile users to public apps. That has no involvement of the SAC. For cloud-connected users, I can basically go through the SSC stack by on-ramping the traffic through the SAC. So I configure it for on-ramp, and then I can go to public applications. Then mobile users that are coming through the SSC stack, I can off-ramp them onto my private applications, and just to complete the picture, I can take cloud-connected users, steer the traffic through the SSC stack, and now I'm in my private app. So any user to any application. Okay? So with one stack. Pretty powerful, I think. And you're not in the business of reconciling two separate networks from two different vendors and so forth. It's a resource in your VPC, and you go ahead and configure it and insert things as you wish. One thing to keep in mind is that this is not to be mistaken or confused with a perimeter firewall that you may need for you to protect application-to-application traffic that may be cutting across different cloud providers or from on-prem to your cloud facility. So that thing that just turned there is supposed to represent a firewall that is implemented with NVA, so appliances that you bring into cloud and deploy. The configuration of all of that and the configuration of what we're talking about here is not at odds with each other, so these things can be modularly integrated without affecting the decisions you made for one thing or the other. So, this is a regional resource, and the question is, where do I deploy it? Close to the users or close to the applications? If I go close to the applications, say for example I have 6 different regions, I'm a global company, and my users are basically being aggregated in those different regions, I may decide, well, that's 6 stacks, I don't want 6 touch points. I'd probably put it where the applications are. I have 2 regions with my applications, choose to do it there. If you choose to do that, that's fine. The traffic will come in through, I don't know if I have a pointer on this, but the traffic will come in through the user regions, it will be secured, and it will traverse the SSC project across regions. And whatever cost that has is the cost that basically gets translated and billed to you, right? So it's cross-regional in the SSC stack, and then we off-ramp in the regions of the applications. One thing to keep in mind is we need to set some custom routes to actually get the traffic back. So if you're going into the blue application region or the red application region, you want to come back through the same channel. Right? And in order to do that, you need to set a custom route that is aligned with the source of the return traffic. So source-based policy routes. So we can use PBR for that, or we can use tagging and custom static routes. If I choose to actually go and set up the off-ramp and the SSC stack in the regions where the users are, then what happens is you could equate this to a cold potato or a hot potato routing type of scenario where I get off the SSC service as soon as I can, and now the cross-regional communication happens in your project, basically in the terms that you may have negotiated with Google. So it's just a consideration of what's your better cost profile. But also there is a performance consideration. This basically goes direct through the Geneva tunnel, and it's all cloud native from that point onwards. In the previous scenario, the SSC provider might actually use IPsec tunnels between their nodes, which brings the performance down significantly. I mean, that was one of the things that motivated all of this work when we started partnering with Palo Alto. So, an interesting thing that we look at is you could have scenarios where you need to connect your users directly to cloud. If you need a big pipe to connect those users to cloud, you've got OT, for example. If you need low latency and controlled SLAs, we basically connect those users directly to cloud. And in those scenarios, you actually can get now the full mix of what we were talking about, where you do on-ramp and off-ramp. We recommend in those scenarios, get your stack close to the users. Right? It's consistent. One of the rules of thumb is always try and inspect the traffic as soon as you can. And that's closer to the users. It's usually user-initiated communications. We can also look at this as in, I have some shadow IT that I need to put in check. Well, by having the model that we're talking about here, you can have an SSC provider that is one company, and you can have your VPNs that bring traffic to the SSC be provided by a different company. If you have a hodgepodge of different shadow IT SD-WANs, you can start bringing them together by doing this. And what I'm showing here is very subtle, but in those user VPCs, I have head ends of SD-WAN. Okay? And those head ends could be company A, and the SSC stack can be company B. And you're in business. You can have different types of these things in different regions. So that's a very quick overview of some of the design considerations. Is basically where do I put the stack? And one of the things that always comes up is I already have an SSC stack in place. Do I need to redeploy this? Do I need to revisit my policies? Do I need to choose new resources? Is this a total redo? And the answer is no. This is basically, you plug it in, you add to the constellation of SSC nodes that you have, and you're basically adding an interface to your stack. Okay, so it's incremental to what you already have. So with that, and we have 1 minute and 24 seconds to answer questions. I'm going to invite the rest of the speakers up here, and who are the lucky 2 or 3 that we can answer questions. Okay, go ahead. There's a mic coming for you.
Oh, it's okay. I don't need a mic, I don't think.
You don't need a mic, but they might. Okay, thank you.
To get turned on.
Yeah, it's on.
Okay, so how do you deal with the government agencies that have to deal with sending that data down to, say, DHS and so forth? How is that broken out? Or is it all considered your part of your own personal network that you don't have to send it, that NetFlow data to DHS? Because you have MTIPS connections today, right? So you've got TIC3 coming out for CISA. How do you deal with these basically point-to-point connections through Google that are essentially extensions of your network? Is that, have you worked with DHS? Is that kind of their policy on that, or you know what I'm talking about?
I do not. Maybe you.
I actually didn't catch your question very clearly.
So if you're a government agency,
Yeah.
inbound and outbound traffic has to be monitored by the Department of Homeland Security. MTIPS connections, if you will, and it's now pivoted to something called TIC3. So they're capturing all that data and inside of the cloud service provider. If your data, if your traffic does not traverse the public internet, you don't have to send it to them.
Yeah.
And so we're trying to figure out from this architecture, is that considered part of an extension of our network, as an agency network, so that we don't have to send that traffic?
So the cloud connected sites would be considered part of your internal network. These are all private links. It's all privately controlled. It's all within your confines. If you have any mobile users that are coming over the internet, using the internet as last mile, at that point you're exposed and you're going to have that requirement pop up.
Yep, same for your branch in the SASE model, right? Those branch remote users have to